Dear students, so following the previous slides for the logistic regression, so we will discuss in this second part the gradient descendant for the logistic regression, that what is a gradient descendant and how it is linked with the logistic regression. So for that one, we need a cost function which we represent by g of theta, where theta is like from theta naught to theta m. Start off with some guesses from theta 0 to theta m, and moreover it does not really matter like what values you start with, but like it's better to initiate all the values from 0. That will be a good practice. And you have to repeat this process, these functions, until the convergence. So like there is we use the derivatives, partial derivatives for the cost functions, okay, g of theta. And then we have like some learning rate which we represent with the alpha. It control basically how big a step we take when we update the theta j, and we update all the theta j simultaneously at a time. It's important to update all the theta from 0 to m. Okay, so there is a more description on that one, and it gives you some tip that uh, this theta function, it doesn't matter that what value you start, but like usually the common practice is to start with the 0, and you have to repeat until the convergence. So this is the equation. So this is a mathematical equation. So those who understand mathematics more, so it will be easier for that what is the meaning of the summation, what is the what is exponential, how exponential works, how theta works. So these are the basic mathematical functions which you must be knowing, or in case if you don't know, so you just consult your mathematics teacher, so it will explain you better in that way. So the final formula after applying the partial derivative, we get this one. So in this one we have resolve the derivative, and after the derivative we get the simplified version. Inference, so how we infer after the learning, after applying the logistic regression. So after learning the parameters, like as we told that there is parameter from theta 0 to m, and we can predict the output of any unseen like x naught to m naught as follows. So how we gonna do it? So we put some threshold values like 0.5. So if it is h of x is h of x is 0 less than 0.5, so we have to go for 0 or no, right? Or fail, or like this kind of thing. So 0, or else if it is greater than and equal to 0.5, then we have to go for prediction 1. So even if it is 0.5, then there is the prediction value would be 1. So the concrete example, in the training phase, we have, let us apply some logistic regression on the spam email. So some of the emails are genuine emails we receive, some are spam email. So Google also classify it, and Microsoft Outlook, they are also classify it, and automatically it sends to the spam emails when if it is not your concern with you. And there's some further classification is done by the Google, like some ads, or some primary email, or some three different classification they do it. So let's apply logistic regression on the spam email recognition problem, assuming, let's suppose the learning rate is 0.5 and starting with the 0, 0, 0. So let's see how it works. So we have, like for example, email A, okay, and then we have it talks about vaccine, okay, and it talks about Nigeria, okay, and it's off. So vaccine the off, so here if you put these values in that one, so it gives y, which is the dependent variable is 1 prediction if you put in that cost function, and in the prediction function. And then in the b, so in the b is these values, if there is a 2 1, I think, yeah, so it gives you 0. So again, but here if in the vaccine is 1 and end is 1, so here it gives you 1. So this is not like the basics, exclusive OR function. You must put these values into the function, and the function will predict you, right? So it's not like a simple exclusive or and. So and then you're gonna predict that whether it's a 1 or here, right? So this is the training set you already have, and it works well. Okay. So now, So one entails that a word like and represent an email that is like email. Okay, okay. So this one is like just giving you some clues. Okay, zero here. That word like and is absent in the email. So and is not here in the email. That is, for example, email B. Okay, so it is giving you some examples related to that one. Okay, let us apply logistic regression on the spam email recognition. And here, like, we give them like, values. For example, word and, if there's and is there, so it's one. If and is not there, is zero. If vaccine is there, is one. If vaccine is not there in the email, so it's zero. Okay, and similarly, the for which is we assign x3. So these are independent variable x1 to x5, and then with the help of this one, we predict y. So five words we have selected some, and these words are called features. So we define six parameters. The first one is that's called theta naught, is an intercept, right? So you can see over here. Okay, there is some further elaboration on that one. Let's see where is the operation to account for intercept. Yeah, so we like accounted for intercept, like it's now this one is all like one. Okay, here like the x naught is one here. Okay, and the feature vector, and this is the feature vector. Vector means like columns, you can say, or features or columns. Like so there are different like names or attributes. Some people call it attributes, and then the parameters are like these vectors. So like it depends. So a recap, so and the recap, what is the gradient descent for the logistic regression. So a cost function is important, we need to have it. And then we have like thetas. Start off with some guesses from 0 to m. Okay, it doesn't like matter if you put like 0 initially, and repeat until we converge to the sequence. So this is the final product which we need to concentrate on this one, right? First, let us calculate this factor for every example in our training set, right? Yeah. So there is some more like, some concrete example, like, this different like values are given. Okay. So here we have how many values? Yeah. Six values, including the 0x from x0 to x5, which is total is six, right? So there are different pairs, and then we have different like, values of x and value of y. And we have theta, and we have like alpha learning rate as well. And then with this function we apply it, and sometimes we get zero for the first iteration, and then when we change it, so the result would be changed definitely. Okay, and then have cost function like this one. Okay, the same thing. And second, let us calculate this equation for every example in our training data set, and every their theta j, where j is between the 0 and m, right? Yeah, this is like some second iteration, and then you go for like further iterations. Okay, yeah. In this one, what we have it, so here we apply that cost functions, and with that one we get some values of 0.5 with the plus, and so some are with the minus. Okay, third, let's compute every theta j. Okay, so let's see how they compute theta j. Okay, and with this one, so the values are assigned to the different like proper positions, and then we get like theta j. Okay, okay, and this one. Okay, and then see again x2. So before it was x0. Okay, if you go back, so here is the value of the value is changing here. I just want to like highlight for you that where is the change. Basically, the change is here. Let me highlight this for you. Okay, with the red color would be better. So this is like basically x0 is changing. Okay, so based on that one, we see that how like things are moving. So just like focus on this one, and then you will notice what is going on. So x1 is changed, and then we get these values, right? Then it will be for x3 in the next step. So these values we are getting like these different learnings. And after that one, x4 we are getting these values. X5 we are getting these values. Okay, and then we have like all the values here, and we are getting the theta. So let us now test logistic regression on the spam email, right, using the just learned, like we learned these values. So initially we got 0, 0, then 0 0.5, and then 0 and 0. Minus 0 0.5 and plus 0 0.5. Testing is typically done over a portion of the dataset that is not used during the training, but rather kept only for testing the accuracy of the algorithm's prediction. In this example, we will test over all the examples that we used during the training, but we need to elaborate the purpose. So these are h of x we have it. So we were looking for h of x with the theta, and these are like, learning rates. So prediction class, so based on this one, as we told that if the value is equal or more than 0.5, then the prediction would be 1. If it is less than that one, the prediction would be 0. So now you can easily see what is the so yeah, so here, like, here, so here what is the going on? So yeah, no misprediction. Yeah, okay, so see, there is no misprediction here. All of the prediction are mostly correct. Here some like, more examples, like some of the training data sets, and then we are like, h of x, we are 0.7, so it is also is it like greater than 0.5, and it is yes. Okay, so and then so because we changed the here the info email, and we k is equal to from 1 to 101001. Okay, somehow interesting, since you consider the vaccine and Nigeria indicator of the spam, right? So sometime vaccine word comes or Nigeria word comes, like, then we have to go for, like, give for consideration. And this is the end of this logistic regression. And next chapter, we will be discussing some more supervised learning, and then we will focus on the unsupervised learning. Take care.